All right, now let's write the logic for buffering the data. So I would like to take another block, and I will take a function block because this comes with a DB, or you can also take a function. It's up to you. I will write it as buffer data. And I would like to write this in SCL actually, which is more convenient way. I will explain you in different steps. So focus on this video because this might get complicated. So let's see, the first step is step 1. What I have to do, the idea is we have to move 2 information. One is the tag information, another is timestamp. Okay. Now, first of all, I have to make sure what I'm getting from this RFID once it reads the tag. Okay, if I go back here and if I show you, or we can also see it here, we had command acknowledge or command end. Okay, command end is the last status I get from the RFID when everything ends, which means when the reading is completed or writing is completed, I get command end at the end. So I will use this bit to start my process of buffering. Okay, that's the starting bit which I want to use. But this command end, if you notice, remains true all the time. So if I show you here, where is the RFID data? Like suppose if I bring the tag, you can see that this command end is true. Yeah, but I don't want to use these continuous signal. I would like to use its rising edge. Okay. So this command end rising edge I have to create in SCL. And how we can do that, there are many ways, but I will show you the way which I would like to use. So I'll write, I will take a tag, command end flag. Command end flag is basically my rising edge. Okay, this I will get from, okay, now I have to open my RFID data, which I can minimize this one. So this is my command end. I will take this one. I will take and. I will take another bit. I will explain you what is that. I will take m command end flag. Now you will see these 2 error lines because I haven't defined these tags. Okay. Now my command end flag is my rising edge. I would like to define it. So define tag, and this tag is a Boolean tag. So I will go to Boolean, and this will go in my static because I want to take rising edge in the static. Define it. Now this is defined. So make sure you, anytime when you want to use a rising edge, define in the static. Okay, because it will reset by some condition, which I will define it here. You don't have to use it temporarily. Okay, and this command end flag is basically another static tag. I will tell you how I will use it, but let me just take it Boolean and define it. Now, what is this tag? So you will use this tag here. So this is just a way to use rising edge in SCL. For example, this tag will be true when I have this RFID command end. So basically, I will tell you what is happening. Now in this logic, if you notice here, let's just zoom in a little bit. This is my rising edge. It says it will come if command end comes from RFID. This is coming from RFID. We have seen here command end and not of m command end flag. Okay, so initially this command end flag is false. Okay, because if the program is executing, this will be false. Everything is false. But if this command comes, and if this is false, its inverse is true, which means this will be true. And as soon as this is true, let's come to the next point. M command end flag, it is reading again from here, which is true. So in the second command, this is true. And if this becomes true, this is not, this will be false. So this will be false in the next cycle. Okay, so it will keep on inverting the status, which means it will first be true because this is false. So this command end flag will be true, and this is true all the time when the tag is in front of the RFID module. And in the next line, because the sequence comes from 1, 2, 3, 4, in the next line, this was true, so this will be true. So when the sequence is completed in the next cycle, this will get false because this was true. I hope you get the idea. And when you take out the tag in front of the RFID module, this will be false. So this will be false, and this will be false again. So this not will be true. And when the tag comes again, this was true, this will be true, and this will be true. So this is just a way to make a rising edge in SEL. So you can try this with your own logic in different applications, but you will find a rising edge. So I will write here as well, generating rising edge bit for RFID and signal. Okay, so this was the step one. We need a rising edge. Now what will happen with the rising edge? Let's check the first. Okay, let's go back to my logic DB, or let's go back here. Now we have to make sure that it should only log when we have an input which says enable logging or enable buffering. So we need an input which will start buffering, and if that bit is false, it will stop buffering. It means we need an input which will start recording the data, or it will stop recording the data. Okay, so we need an input. So let's call it input as start logging. Start logging, and this is my input boolean, which makes sense. And one more thing, if you are starting logging the data into a database, and let's suppose this tag is already present, you know, somebody took the tag, started logging, and bring it back here, which is not recommended, but we have to make sure our program is secure enough to generate an error if you have the same tag coming in the process. So that is also a kind of situation that if you're logging, you should not get the same tag again. Okay, so in the input, we will also write tag already present. Okay, so this is a kind of error which we will also use. So I'm going to use it in out. I will tell you why, because we will use this as an input or as an output. Error tag already present. That's also my boolean. So let's say these two situations are good enough to start. So I will write here command check tag validity, maybe that is tag. There are two validities. Tag should not be already registered and should not be 0. I mean, the tag information should not be 0. It means it's not valid, because if it's 0, what's the point of writing it? So now these two conditions I will write with if statement. Now if this command end flag comes, because if this rising edge is here, so I'll write if command end flag. And now we have to make sure RFID should not be equal to 0. So I will take this one. Now here I'm just reading the first information. Okay, sorry, should not be equal to 0. I'm just reading the first register, first address 0. I'm not caring about 2, 3, 1, 2, and 3. Let's just talk about just first value. If this is not equivalent to 0, and if you have a rising edge, okay, these are the two conditions we need to do initially. Okay. Also, you can write maybe two more conditions. For example, if we have defined start logging, so we have to make sure if start logging is enabled, and we can also define if there is no error. So that is also a good idea. So, and if there is no error, it will be not, because if there is an error, it will be true. If this is an error, this will be true. And if you take a not, this is, if there is no error, this will be 0. So its inverse will be true, which makes sense. Yeah. Okay. So these are the 4 conditions. start logging, user has enabled the logging. There is no error. And we have a rising edge from the RFID coming, and RFID information is not 0. Okay, these are the 4 conditions. Now, what do we need to do? We need to store, okay, we need to check if this RFID is registered or not. Okay, how we can do that? So we need to define some information which should come maybe in the static. So in the static, I will write, maybe let's try with job. And here I will take an array. I will tell you why. I will take an array of structure, and I will take up to 5. Okay. Now, in the job, what we are storing RFID tag information, and we are storing time. Okay, and let's say we also store job ID. What is the count of this ID? If it is the first object or the second object or the third object, we can also do that. So in the structure, I will define RFID, and this is an integer. And here I will write job ID. This is also integer. And the time. So I will write, let's say, process time, and let it be DDL. So I have my process time, year, month, day, hours. So this is copied to all the structure because this is my array of structure. So I have to just define in the first one, and it will automatically link to all the array. Okay. We do that because we need to store the information in the buffer. So this is my buffer. I'll just take buffer of 6 elements from 0 to 5. Okay. Now I have to check if this tag is already registered. That's why I use this buffer. So we have to check if the RFID information which is here is already in any of this RFID information, which is 0, 1, 2. So we have to check this. And if you have multiple elements to check, the best way to do that is using a for loop. So let's take a for loop. So before taking a for loop, I also have to define some elements here because we need to define the loop. And for the loop, we need to define some variables. So let's say I take C here. Okay, wait, C here, and the C is going to be my integer, not a structure. Oops. Oh boy. So C is my integer. For C, so let's start the C, start from 0 to 5. Now why 5? Because this is 0 and 5. So we have to check this whole structure of whole array elements from 0 to 5. Okay. Do what it will do. Now if, I will again write if. Now we will take this RFID here. Now instead of 0, I will write #C. Okay. If this is equivalent to, now the C means job 0, 1, 2, 3, 4, 5. So job 0 dot RFID, which means this one. So when C will be 1, which will be job 1 dot RFID, because C's will go from 0 to 5. So this variable will be from 0 to 5, if you know for loops. If this is equivalent to my RFID value 0, this is my condition. Okay. If these are equivalent, then what will happen? It means if this RFID value 0 is present in any of this job RFID, which means if it is already registered, we have to raise an error. Okay, that's where this error tag present will come. Okay, so I will make sure it will come here, and this will be true if this happens. Okay, okay, we have to write colon. And if this is coming, if there is an error, it will just go out of the loop. So I will write go to, let's say x1. x1 is my label. I will tell you where I will use it. And then you end the loop and if, and you end the loop and for. Okay. So this piece of logic I will explain again what will happen. Here we generate the rising edge, you understood. Check tag validity, and tag should not be registered and should not be 0. Start logging come from the user if you're starting the logging command. Not error already present, it should not be present. It means there should not be any error. Command add flag means we have the rising edge, and RFID should not be equivalent to 0. So once these conditions fulfills, there is a for loop which will check from 0 to 5, which means it will check in this job data from 0 to 5 that if this RFID data inside the job is equivalent to RFID data which is on the input, then we have an error which will be true. If there is no error, it will just go out of the loop. If there is an error, it will go to x1, which I will define later. But if there is no error, this for loop will complete and it will continue further. And what it will continue, now we are going to write that. So next situation, if RFID is not registered, this was just to check if it is registered. Now if it is not registered, we have to register it. Register the tag, register or buffer the tag in the next available slot. Okay, now what is next available slot? It means if it is the first tag and it is not registered before, it will store the RFID information here, job ID here, and the time here. Okay, so we have to move the value, job ID and time. This is what we have seen here. We have to move 3 values: tag, timestamp, and also job ID, which I think is a good idea. Okay, if it is not registered, now we have another loop for, now in this case I will take maybe D for T 0 to 5 do. Okay, now we have to first search for next available slot, which means if this is already filled, then job ID will not be 0 or RFID will not be 0. Okay, it has some information. If this next slot is empty, then by default these 2 values will be 0. Okay, so we'll take for, and then we'll write if, and let's take RFID equivalent to 0, and we can also take another one just for the safety. Job ID is equivalent to 0. These are the 2 conditions. Then what will happen? Now first we need to increment this job ID, so I will just write here job ID, and here, okay, instead of 1 I will use this because it's a for loop, so it will be D, and this will also be D. It will check all the registers here, all the array elements. This will also be D. Okay, this job ID will be incremented, so this will be basically D plus 1. Now what does it mean? So for example, it's at 0. Okay, so this is reading here, this is 0, and if the first element is 0, suppose nothing is written, which is true, so this is 0, and the first job ID is also 0, which is true because nothing is written, then job 0, job ID, which means job 0 and job ID, what should have here? The first job ID. So D was 0 plus 1, so 1 will be written in the job ID. That's why I've written D plus 1. Let's suppose 1 is filled, 0 is filled, and 1 is not filled. So when the 0 will come, the situation will be false. It will go to 1. So at 1, when the D is 1 and RFID is 0, which is okay because this is not filled, and job ID is also 0, so job 1 and job ID, so job 1, job ID will be, this was 1 plus 1, so this will be 2. So this will be 1 and this will be 2, and so on. It will continue the loop. So that's why hash D plus 1, job ID will be incremented. And what will be in the RFID? So let's bring that here. RFID, again, I have to take a variable. This is necessary that you should know for loops, because if you don't know for loops, this is a very basic one, You really need to know for loops. What I mean to say, that's why you will understand why this variable comes here. Okay, so when we have the next empty slot, we have to move the RFID value. So just take this value here. Okay, similarly we do with the process time. We take the process time, and here instead of 1 I will put variable #t, and here I need to move my current time, okay, which was in my current time is not in the buffer data. Current time is in my logic DB. So go back here, time parameter. So this will move my current time to my job process time. Okay, so that's how a timestamp will be stored. RFID information will be stored, job ID will be stored, which will be automatically incremented. Okay, so once this condition is true, what we need to do, we need to go out of the loop. So I will write go to x1, because we don't want the loop to continue further. Once the condition is true, we write the value and we jump out of the loop. Okay, so now I will end my if statement and my for statement. This is recommended to write the end, not recommended but compulsory. So now that's my x1, sorry, where I jump out of the loop. Basically it will be colon, and I will end the loop statement which was open before. So end if. That's your logic. That's your logic to buffer the values. Okay, I will write here step 2. Okay, but now we should also write some information. If your buffer is full and you want to empty your buffer, how you can do that? It's actually not so difficult. So I will write here clear buffer, okay, because we need to test it. Now clear buffer is also an input, so I have to define this here. Clear buffer is my input. So if user clicks clear buffer, or if you user enable clear buffer, this comes here, then what should happen? Then we have to reset all these values in job 0, job 1, and job 2, 3, 4, 5. RFID should be reset, job ID should be reset, time should be reset, everything should be reset. Okay, so just because we are using all of these elements, we need to again run a for loop. Okay, that's very convenient. So I will write for. Now I also need a variable for that. Let's take I. So for #i colon 0 to 5 do, and then I will just write here job 0 RFID. Here will be #i. RFID I would like to make 0, so just put 0. And similarly, why do I have an error? Not 1. Similarly, we take job ID equivalent to 0. And the time, oops, why it's 1 again. And the time again. So in the time you can see there's a lot of information in the time. So I can basically use my reset time, which is my default time. I'm not putting anything in that, so it will be. Now the default time here is not basically 0, but if you see here, this is a default time 1970 0101, but I will consider as the time which is not written. So that's why I took this reset time here. So my process time will be 0, and after that I will just end my for instruction, and I will end my if instruction. Okay, now one more thing, and that's the last thing which is left. We have written here about the error if tag already present. If this error is coming, we need to reset this error. Okay, so to reset the error, we also need another input. So here I will write reset tag present error. Now, another comment, reset error. So if our error is there, so if user reset the error, then what will happen? Our error already tag present should be false, and you end the if command. Oops, basically like this. So if a user reset the error, it will reset this error already present, which was made true here, it will be false. Okay, I will explain you what will happen once we run a trial. So this was your logic. So basically buffer data is completed. Now I would like to call it in the main program. So this was the logic. I can rewrite for read write time, and I need another network logic for buffering data. So because this video is getting very long, I would like to split that video. So let's continue that in the next video. See you soon.